Today we are dealing with problems on exercise 7.2. First of all, we'll do a direct problem in which we need to use the section formula. And you can read the question number 1. Find the coordinates of the point which divides the line segment joining the points -1, 7 and 4, -3 in the ratio 2:3. This is direct application of what we have learned. There is a line. The coordinates of the lines are -1, 7 and 4, -3. This line is divided in the ratio 2:3 by some point. Let us take the points as A, B and C. I can say C divides AB in the ratio 2:3. So from here I am taking this as x1, y1, this as x2, y2, and the ratio, this is m1, this is m2. So I can apply the formula. The formula is xy is equal to m1 x2 plus m2 x1 divided by m1 plus m2. Then m1 y2 plus m2 y1 divided by m1 plus m2. These are the formula through which we can find xy. Xy is the coordinate of C. So we can apply this here. So xy will be equal to m1 x2, that is 2 into 4, plus m2 x1, 3 into -1, divided by m1 plus m2, 5, comma, m1 y2, 2 into -3, plus m2 y1, 3 into 7, divided by again 5. On solving this, 2 into 4, 8, 3 into -1, -3 divided by 5, then 2 into -3, -6 plus 21 divided by 5. So the answer is 5 by 5. 5 by 5. Then this is 15 by 5. So 5 by 5 is 1. Then 15 by 5 is 3. So 1, 3 is the coordinate of the point C, which divides the line segment AB in the ratio 2:3. This is a direct application of section formula. So this is our next question. In this question, the question is find the ratio in which the line segment joining the points -3, 10 and 6, -8 is divided by -1, 6. There is a point of division is already given in the question. We can represent the situation as follows. This is a line. Now, this is, let it be A. This is B. The points are -3, 10, and the coordinates of B is 6, -8. Now, it is divided by another point. The point is given as -1, 6. And we need to find in what ratio it is divided. Okay, if it is C, then we need to find in what ratio C is divided AB. That is our question. Let us take the ratio of division m1 is to m2 as k is to 1. Okay, so I am specifying that the ratio of division, that is m1 is to m2, is assumed to be k is to 1. So here the points xy is, on applying the section formula, you are going to get this coordinates of this point, and it is already known, that is xy is a known quantity here. Now here this is x1 y1 and this is x2 y2, and the ratio of division we took as k is to 1. So we can apply the same formula here. If you want to find xy is already given here. Xy, this formula is m1 x2 plus m2 x1 divided by m1 plus m2. Then m1 y2 plus m2 y1 divided by m1 plus m2. This is the formula. Now we are going to apply in this formula. You already know the value of xy, and that is -1, 6. You can write that here. This is equal to m1 x2. The value of m1 is k, x2 6 plus m2 y1 divided by m1 plus m2. So this is equal to k plus 1. Now again m1 into y2, that is minus 8, plus m2 into y1. It is not minus 10 but 10, divided by k plus 1 again. So using the formula, the coordinates is this, and we already know the coordinates are minus 1 and 6. Now we can simplify this to 6k minus 3 by k plus 1 and minus 8k plus 10 by k plus 1. So I can say x is equal to minus 1 here. The x coordinate is minus 1 here and the y coordinate is 6 here. So to find the value of k, you can either equate the x coordinate to x coordinate or the y coordinate to y coordinate. Here I am equating the x coordinate. So I will get 6k minus 3 divided by k plus 1 is equal to minus 1, or 6k minus 3 is equal to minus 1 into k plus 1. That is equal to minus k minus 1. Minus 1 into k plus 1 minus k minus 1. Now this is equal to, you can take this minus k to the left hand side. So it will be 7k equal to minus 1 plus 3, that is 2. Therefore you can write the value of k as 2 by 7. If you want to cross check, you can take this y coordinate and you can equate this to 6. You're going to get again the same value for k. So we got the value of k as 2 by 7. Now look at the ratio of division. K is to 1, or now we can write it as 2 by 7 is to 1. If you want, you need to represent the ratio in whole numbers. For that, you can multiply both the sides of the ratio with a whole number. So here it is 2 by 7. To make it whole number, you can simply multiply it with 7 on the both sides. So it will become 2 is to 7. So this is the ratio in which the line segment AB is divided by the point C. The ratio of division is 2 is to 7. This is the second type of problem we can expect. So this is our next question. Find the ratio in which the line segment joining the points 1, minus 5 and minus 4, 5 is divided by the x-axis. Also find coordinates of the point of division. So first of all, we need to find the ratio in which the line is divided, and also we need to find the coordinates of the point of division. Now we can represent the situation as follows. It is a line. The points are 1, minus 5 and minus 4, 5. So I can name it as A and B. Now there is another point, let it be C, which divides the line segment joining AB. I don't know the ratio of division and I don't know the coordinates of this point. But look at this statement. It is divided by the x-axis. So I can assume that C is a point on x-axis. Okay, C is a point on x-axis. So if it is a point on x-axis, then its y coordinate will be 0. The y coordinate will be 0. That is the hint given in the question. So I can represent the coordinates of this point. Let it be xy, or I can specifically say it is x0 because it is a point on x-axis. If it is a point on x-axis, then the y coordinate of this point will be 0. So again, let the division be in the ratio k is to 1. You can apply this section formula. I'm not writing the formula now. I'm directly applying that in the question. So x0, that the point of division will be equal to m1 x2. Here m1 is k, then x2 is minus 4 plus m2 x1, 1 into 1 divided by k plus 1. Again, k into 5 plus 1 into minus 5 divided by k plus 1. These are the points. Now you can simplify. This will be minus 4k plus 1 by k plus 1. And this is 5k minus 5 by k plus 1. If you want, you can cross check. K into minus 4, then 1 into 1. k into 5 and 1 into minus 5. Okay. Now, again, you look at the statement x0, the point of division is equal to minus 4k plus 1 by k plus 1 and 5k minus 5 by k plus 1. In this question, you don't know the value of x, but you know the value of y coordinate. So you can equate 5k minus 5 by k plus 1 to this 0. Okay, the 0, the y coordinate. So from here, you can simply write 5k minus 5 is equal to 0. Therefore, 5k is equal to 0. Sorry, 5k is equal to 5 or k is equal to 1. 5 by 5, 1. So we can simply say that the ratio of division k is to 1 is 1 is to 1 here. It is midpoint. Now we need to find the coordinates of this point also. You know the y coordinate is 0. Now you need to find the x coordinate. You can use different methods to solve this. You know the value of k, so you can apply the value of k here and you can find x from here. Or you can simply apply the midpoint theorem to find this now. So we can apply here x is equal to minus 4k plus 1. That is k is already 1 here. So minus 4 plus 1 divided by k plus 1. Minus 4 plus 1 is minus 3 divided by k is 1 here. So 1 plus 1, 2. So the point of division, that is x0 will be equal to minus 3 by 2, 0. So the ratio of division is 1 is to 1 and the point of division is minus 3 by 2, 0. So this is the next question. If a and b are minus 2 and 2 minus 4 respectively, find coordinates of P such that AP is equal to 3 by 7 AB and P lies on the line segment AB. So we are talking about a line segment. This is my line segment. It is named as AB. The coordinates of this line segment are minus 2 and 2 minus 4. Then there is a point P. P lies on the line segment. So P is in between this line segment. Let it be here. So it is P. Now AP is equal to 3 by 7 AB. This is the relation given here. AP is equal to 3 by 7 AB. Or you can take that AB to the left hand side and you can simply write AP by AB is equal to 3 by 7. From this you can conclude AP is equal to 3 and AB is equal to 7 since this is ratios. So AP is equal to 3 and AB is equal to 7. Now AP is equal to 3 and AB is equal to 7. If so, then we can find the value of BP. If AP is 3 and AB is 7, then PB will be 7 minus 3, 4. So this must be the biggest part. So I can mark P like this. So the ratio of division of this question is 3 is to 4. So here this is x1, y1 and this is x2, y2 and the ratio of division, that is m1 is to m2 is 3 is to 4. This is the hint given in the question to find the ratio of division. Again, AP is equal to 3 by 7 AB. From this you can write AP by AB equal to 3 by 7. So we can conclude AP is equal to 3 and AB is equal to 7. If AB equal to 7 and AP is equal to 3, then PB will be 7 minus 3, 4. This is the way we need to find M1 is to M2. Now this is a simple problem. You can apply this three things in your formula and you can find by yourself. So this is the next question. Find the coordinates of the point of trisection. Points of trisection of the line segment joining 4 minus 1 and minus 2 minus 3. So I can mark the line as follows. This is 4 minus 1 and minus 2 minus 3. And we need to find the coordinates of the points of trisection. What is meant by trisection? Trisection means into 3 equal parts. So we are dividing this line AB to 3 equal parts. So let it be the first part, the second part, and this is the third part. We can name this as PQ. So AP is the first part, PQ is the second part, and QB is the third part. And you should remember one thing, these are three equal parts, or we can say AP, PQ and QB are of the same length. So if this is 5 centimeter, this will be also 5, this will be also 5. So I can in general say the ratio of division is 1 is to 1 is to 1. The ratio of division will be 1 is to 1 is to 1 because these are of same lengths. Now, first of all, you just consider the points A, Q and B. These are the points you need to consider, A, B and Q. So I can say this part is 2 and this part is 1. This is A, this is B and this is the point Q. You know the coordinates of A, that is 4 minus 1, and know the coordinates of B, that is minus 2 minus 3, and you know the ratio of division, that is here it is 1 plus 1 2 and this part is simply 1. So the ratio of division is 2 is to 1 here. So using section formula you can find the coordinates of Q here. So M1 is to M2 is 2 is to 1. So the points of division, that is Q will be equal to, I am taking it as XY here, XY is equal to M1 into X2, that is M1 into X2 means 2 into minus 2 plus 1 into 4 divided by 3, then 2 into minus 3 plus 1 into minus 1 divided by 2 plus 1, 3. So you can calculate. This is minus 4 plus 4, 0. 0 by 3 is again 0. Now here it is minus 6 minus 1, minus 7 by 3. So this is the point of Q. So Q is 0 minus 7 by 3. You can write the coordinates of Q as 0 minus 7 by 3. So again we need to find the coordinates of P. Now we just think about A, P and Q. That is the simplest way. If you want, you can again take A, B and P. That's all right. I'm telling you an easy method. Just think about A, P and Q. If you want, you can mark the line again. So this is A, P and Q. The ratio of division is 1 is to 1. Simply 1 is to 1 here. The easiness is you can take midpoint theorem to find P now. You know the coordinates of A, that is 4 minus 1. You know the coordinates of Q, that is 0 minus 7 by 3. Now you can easily find the coordinates of P by midpoint theorem, and that is midpoint theorem, xy is equal to x1 plus x2 by 2 and y1 plus y2 by 2. So you can take the first coordinates as x1, y1 and the second one as x2, y2. So simply the points of P is, if it is xy, then it will be x1 plus x2 by 2, that is 4 plus 0 by 2 and minus 1 plus minus 7 by 3 by 2. So 4 plus 0 by 2 is simply 4 plus 4 plus 0, 4 by 2, 2. Now here it will be minus 3 plus minus 7, minus 3 minus 7, minus 10 by 6, minus 10 by 6, or we can say it is minus 5 by 3. So these are the points of division 2 minus 5 by 3. 2 minus 5 by 3. So in this way you can find the points of trisection. So this is our next question. Find the coordinates of the points which divides the line segment joining A minus 2, 2 and B 2, 8 into 4 equal parts. In the previous case, it is into 3 equal parts. Now it is to 4 equal parts. So this is AB. This is AB. A, B, and the coordinates are 2, 8 here, and here it is minus 2, 2. It is divided into 4 equal parts. So now it is into 2 equal parts. Again, you need to divide into 4 equal parts. This is the first part, this one is the second, this is the third part, and this one is the fourth part. Now we need to find the coordinates of these 3 points. Let it be P, Q and R. You need to find the coordinates of P, Q and R. Again, we are looking into the simplest formula. Now here it is 1, 1, 1, 1. If you want, you can take like this. Now consider A, Q and B. A, Q and B. The situation is now A, B is divided by the point Q. Now if you want, you can calculate the ratios. It is 2 here and it is again 2 here. If you want, you can simplify the ratio again into 1:1. Or Q is the midpoint of AB, right? Q is the midpoint of AB. So you can simply find the coordinates of Q by midpoint theorem. So the points XY will be equal to x1 plus x2 by 2. That is minus 2 plus 2 by 2 and 2 plus 8 by 2. Minus 2 plus 2 by 2, 2 plus 8 by 2. That is 0 and 5. These are the points. 0 and 5. So we found the coordinates of Q, that is 0, 5. Now again look at the question. We can again apply the same theorem, midpoint theorem, to find P and R. Now consider A and Q. P is the midpoint of AQ here. So if you need to find the coordinates of P, again you can use the midpoint theorem. And the coordinates of P, let it be XY again, which will be equal to minus 2 plus 0 by 2 and 2 plus 5 by 2. Minus 2 plus 0 by 2 and 2 plus 5 by 2. It is equal to minus 2 by 2, that is minus 1, and 2 plus 5 by 2, which is 7 by 2. So the points of P is minus 1 and 7 by 2. Again, to find R, you can use Q and B. R will be midpoint of Q and B. So let it be XY, the points of the coordinates of R. Then you can simply write 0 plus 2 by 2 and 5 plus 8 by 2. So the points are 1 and 13 by 2. So the points of R is 1 and 13 by 2. This is the case in which the line segment is divided into 4 equal parts. So this is the next question. If 1, 2, 4, y, x, 6 and 3, 5 are the vertices of a parallelogram taken in order, find x and y. So this is the parallelogram and now it is 1, 2, this is 4y. You must write this in an order. This is x6 and 3, 5. Now we need to find x and y. That is the question. How to find x and y? Since this is a parallelogram, you can mark the diagonals first. I am marking the diagonals now. These are the 2 diagonals. Now, if you want, you can name the parallelogram. Let me name it as A, B, C and D. Now, the diagonals are AC and BD. So, this point will be the midpoint of AC as well as the midpoint of BD. So this point will be midpoint of both the diagonals. That is a method through which we are solving this problem. So first of all, you just take AC. Now the coordinates of A is 1, 2. Now the coordinates of C is x6. And you can find this point, let it be O, using the midpoint theorem. So O will be equal to, let it be xy. This will be equal to 1 plus x by 2 and 2 plus 6, that is 8 by 2. This is the formula for O from diagonal AC. Now again O is the midpoint of the diagonal BD also. So now you consider BD. Now the points of B is 4y and of D is 3, 5. Now again the midpoint O, that is xy, will be equal to 4 plus 3 by 2 and y plus 5 by 2. So this 2 coordinates, that is 1 plus x by 2, 8 by 2 and 4 plus 3 by 2, y plus 5 by 2. This refers to the same point O. So you can equate the x coordinate and you can equate the y coordinate, through which you can find the value of x and y. So I'm equating the x coordinate now. That is equal to x plus 1 by 2 equal to 4 plus 3, that is 7 by 2. You can cancel this 2 and x will be equal to 7 minus 1, that is 6. Now you can equate the y coordinates, that is y plus 5 by 2 will be equal to 8 by 2, that is 4. Now from here y plus 5 equal to 8 and y is equal to 8 minus 5, 3. So the points of this point xy, sorry, there is not, we need to find x and y. X will be equal to 6 and y will be equal to 3. So this is 6 6 and this is 4 3. We need to find x and y. X will be equal to 6 and y is equal to 3. So these are the points.